Good. Then welcome everybody to the May 18th edition of the TVM Community Meeting. As always, we will start recording now, or we actually have started recording now. So if you don't want to be seen or heard, please turn off your microphone or switch off your camera. So the topic for today is the target pre-RFC, pre-processing RFC. But before getting started, is there anybody new here in the audience who feels like he or she wants to introduce him or herself?
I might give a short introduction about myself. I just joined TVM recently. I'm not yet a contributor to TVM, but I will soon become one. And yeah, that's my short introduction so far.
Okay, nice meeting you.
Nice to meet you as well.
Okay, cool. Then I think we can get started with our first and only discussion topic for today, which is the target preprocessing RFC.
Cool. Okay. I'll share my screen if I can find the right one. Oh, cool. So you should be able to see the RFC on the screen.
Yes, we can see it, Chris.
That's a really good start. So yeah, I'll start with the problem that we're trying to solve with this RFC first, which is that when you want to figure out like what features your architecture supports, like when you're looking at the schedules or what optimizations you might make. Currently, TVM distributes these across a number of different files, kind of adds them as and when you actually need them. So like this is a recent one which sniffs the actual CPU specified. We've got some that sort of live in the legalizations files, and some of these are duplicated around. And then we've even got some that are registered via the packed function registry. So there's a variety of different ways of inspecting the target to figure out whether it supports certain optimizations. And this just makes it challenging to figure out what your target might do. So what we want to do is try and consolidate all of those places into a single step when you're instantiating a target instead, by introducing some pre-processing hooks on the target kinds. So when you instantiate something like a C target, you would be able to say, hey, I've got this CPU, and you'd then be able to ask, oh, well, I gave you that CPU, so if you have information about it, what can it do? Which means that all those places can just go, target.arch, and choose a more specific thing to do directly from the pre-processed target. We sort of thought it was reasonable as well, because we select keys based on, you select schedules based on keys in the target, is then to extend it out like this, which is, oh, we've told you about this CPU, so you kind of know what CPU it is, so maybe you can tell me what keys it should have, and select better schedules based on them as well. So those are the pre-processing hooks that we're aiming to add in a sort of similar way to we added the target hooks. We wanted to make it sort of a generic process that could be applied uniformly across different target kinds. This is quite challenging to summarize into the RFC, discussing with Christoph. Apologies for my pronunciation, on the fact that we have different targets that exist at different levels. So like C is kind of like, I'm going to output some C, and it might have many different CPUs and different architectures associated with it. whereas something like CUDA is kind of just scoped to outputting CUDA specific to that platform or that series of libraries. So the RFC tries not to be too prescriptive on how we put together the preprocessors. It instead just says we're going to define a series of preprocessors that look like this, essentially taking the attributes of a target after it's been instantiated and quickly replacing the architecture features from the outputs of the preprocessor. Does anyone have any questions thus far?
Can you maybe go 1 or 2 steps back? I'm not fully, I think I haven't fully understood the whole motivation for the RFC in full detail yet.
Yeah. Okay. So primarily, like across this list of files here and different places where we're inspecting the features of our target, they're sort of spread out, and there's some duplication, and there's different strategies that different parts of the code base employ to say, so for example, on the Codex M4, it has the DSP extensions. And that logic to say, oh, I'm a Codex M4 is in an ARM ISA file, it's in the SimSysNN compiler attributes file. And then you'll see similar duplication or different places for processing different architectures in different ways.
Like a way I think about this is that, like, if you have a schedule that relies on a particular instruction, you need some way to decide if you should consider that schedule as a valid optimization strategy, given the target architecture that you're compiling for, basically. So that's one of the kinds of decisions that you might make here. But I think that there are other like such decisions that mostly involve knowing things about what it means to be, an x86 CPU or an M4 CPU, that would change how you handle optimizations enabled in the compiler, basically.
Okay, totally makes sense. Thanks for clarifying that.
Cool. Thank you for the question. So that then, yeah, what we essentially want to do is replace all those places that we use utilities or checks on the target with this extra property on the target, which is the .arch, which contains all of those things that you want to know about the architecture, but pre-processed when the target is created. And that means that we have one place that we can look at the pre-processing and one place where we can make sure that pre-processing works. But also there's some consistency across our schedules then as to where they do look. So as part of this as well, we need to look at the existing attribute preprocessor, which does attribute to attribute transformations. It's currently called preprocessor. We can rename it to attribute preprocessor or ATRA preprocessor, so it lines up. And we are intending on using the same dict atras object, which is used for attributes, just with another property on the target called arch to reflect architecture. And we're going to wrap it nicely with Python essentially to get that .target.arch. Whatever your field is output. I think the interesting thing is that all of this is done with the same sort of map of string to object ref, or map like a dictionary basically of architectural features. So it's kind of whatever you want to put in and whatever's relevant to your architecture that you can add to the target. Other things like LLVM have objects for this and more structure around it. But in this case, we've just sort of gone with the most, flexible starting point to see how it goes. And yeah, I think the alternatives were kind of like we iterated through them. One of them is that we just keep abusing the attributes, which is, kind of, it means that your target, when it's created, either has to have all of the known attributes on target kind. That seems really bloated and difficult to manage. Or you have attributes that appear on your target that are not listed in target kind, which is, again, like kind of unclean. So we wanted to split that out. And then the other one is just to extend the utility functions or wrap it in some kind of other class. But whilst we're cleaning up, it makes a lot of sense to process your inputs only once so they can be used across as many times the target gets inspected within the compilation flow. So we wanted to add the pre-processing hooks rather than these extra utility functions. And I wanted to quickly note that this is sort of, again, similar to what Clang, LLVM, GCC, most things that take like these inputs so you can tell them a CPU or an architecture or something to tune for, and they'll pass it back out into the various flags that you've given initially. So we're kind of aligned with what other compilers are doing here.
One question I had was just like, should we scope what belongs in, art versus attributes to any particular, boundary, or is it sort of just anything we could compute based on the CPU name? Or
I think so. We could. I know that there are rules in LLVM where they specify the MCPU. I think it's mAttra and mTune are used mostly for getting the feature list. I don't know how that plays out with different targets in TVM though. That's my only concern with trying to clamp it down too early, because we output to C or LLVM or any number of other libraries which may have their own attributes and their own conventions for using those.
Yeah, that makes sense to me. I mean, I think also just starting out with something and then seeing how we use it, and kind of organizing after we've seen some example usage probably makes more sense than trying to do it now. Another question I had too is, and I think this might have been kind of discussed on the thread a little bit, but what if we have C and LLVM that are that can be seen as identical targets for some set of CPUs. The main difference just being that one of them generates LLVM bitcode and one of them generates C bitcode. But as far as enabling schedules and things like that, the CPU is the same between the two of them, and theoretically we should be able to share the architecture parser, I would think, or sorry, the architecture preprocessor. So I guess is that kind of the intent with the with the function attribute here? Yeah,
I think I haven't made it as clear as I could, because there was definitely discussion around this. So in this section, I sort of it's like one line which I left in, which is the CPU preprocessor can utilize the ARH64 preprocessor. So if you get something that looks like it's ARH64, you can then drop down into the ARH64 preprocessor, because that is more sensible than trying to put all that logic into the CPU. And as long as the signature of the preprocessors is the same, you should just be able to pass it straight through. So that's kind of the intention for stuff like target C and target LLVM, is that you'll have probably a top level CPU preprocessor, which has some logic as to when it calls out to those various other preprocessors.
Yeah, one thing I could see where this could go is it kind of reminds me of how cogen, different LLVM cogens inherit from a parent cogen. So I think, correct me if I'm wrong, but I think there's like x86-64 cogen for LLVM, and that inherits from CPU. And it sort of makes me wonder if we should be organizing these with the cogen kind of similar to like the UMA organizational philosophy, or if we should keep them separate. And I think having flexibility is probably good, so this might make sense, but maybe this is something else that should go into UMA or something once it's landed.
I think it's a really interesting, I think if you follow that thread along a little bit further as well, it gets back to one of the questions that was raised on this RFC around whether LLVM and C are the right level for the target, because the target could be that like x86 rather than LLVM, and then your preprocessor would be more specific. So I think there's multiple ways of addressing that, and some are more invasive than others. I don't think we typically use too much. We don't have to use too much inheritance here, though, as they're pretty pure functions.
Yeah, I think that all makes sense to me. So cool. Yeah, those are my questions.
Sounds good. So any more questions from anyone else in the audience?
Hi, Chris, can you hear me?
I can.
Oh, okay, great. Yeah, I was having some audio issues here. Hi, folks. It's just a question about the target object in the case where we have a heterogeneous, you were executing like on U55 and on a M4. So my question is, if we keep the info for the U55 in the same target object as we do for the M4, Cortex-M4, or if they are separate targets, how do we manage when we have, a accelerator, for instance, if the accelerator is meant to be kept into a separate target object, and if it changes something with that RFC.
So currently the Ethos U isn't like 100% a target, and the way its parameters get passed is through a sort of side channel that BYOC, the external code generators, use to pass their arguments around. So I think the first thing is that ideally Ethos U would be represented by its own target type, which means that then you can have like a list of targets where you can look and see there's a target C, there's a target Ethos U next to each other, which means they can have their own independent processing in this in sort of the world where this RFC is landed.
Okay, I see. Yeah. So the U55 will not be a single target object in this case, right?
It would be target Ethos U, and we'd specify the type of micro MPU to use. And it would be in the list. There'll be 2 target objects, one for the CPU and one for the micro MPU.
I see. Okay, yeah. Thanks for clarifying that. Sometimes I do get confused about how we represent the target. So yeah, this is good. Okay, I see. Thanks, Chris.
Yeah, one thing is like, I don't know if this necessarily applies to Ethos U or not, but I think that you could imagine a case where perhaps like a accelerator feature was not available unless a particular target host was in play. So it, maybe there'll be a point in time that we have to think through what exactly these preprocessors could actually inspect, basically, to compute their attributes.
Yeah,
But
that's interesting. Is like, do you think that we should have a target host passed into the preprocessor to know what the host target is?
yeah, or maybe the whole list of all the targets. It seems like this is kind of, branching out into the other discussion we were having about I guess compilation config or some related topic there. So maybe best to come back to this after that we finish settling that.
Yeah, true. I think also Christoph was looking at like potentially doing another RFC around splitting out the targets, so that may impact at what level the different targets exist at, and maybe help make it a bit clearer at least.
Yeah, that makes sense.
Cool. Sounds really interesting and advanced. So any further questions or comments? Okay, then thanks a lot, Chris, for Chris, are you actually done?
Oh yeah, sorry. Yeah, that was the end of the RFC. The only other thing that I had was that like LLVM and GCC have custom file formats for describing target features. So maybe in the future one day, but that was the only other thing I hadn't talked about yet.
Okay, cool. Then thanks a lot for the great presentation. Looks like a really, really cool topic. Thanks also for the audience for the great questions here. So in the beginning, I forgot to ask, are there any other important topics that came up to anybody that we could discuss spontaneously? I think we have some time left in this meeting today. Does anybody have the urge to discuss an upcoming topic?
Yeah, or if anyone has any thoughts on topics you'd like to see, next week or something like that as well. Those are good things to bring up. But
Absolutely.
Yeah, we have a couple different ideas on deck too. So
for next week, maybe we could discuss the UMA RFC, at least the progress of it. So we have had a lot of community discussions in the thread, and maybe we could move it to this meeting to go to a version 1.0 with this RFC.
Yeah, sure. I think that sounds like a good idea.
Yeah, there's Paul, Christoph, who have been involved heavily, but also Manupa. So maybe we could bring this to a version where everybody agrees, and we can kind of finalize the first version.
Yeah, sounds good to me.
Cool.
Yeah, that sounds good to me. And we'll also, we're kind of at the moment working to upstream kind of the work that we've done with CI management. So if someone wanted to make a change to Jenkins and install a plugin, or if they wanted to, add another workflow to our Jenkins, like a nightly build or something like that, you could fairly soon we'll be able to do that by submitting a PR basically. And so once that's kind of upstream with some instructions on kind of how to use, we'll give a presentation about that, hopefully in the next couple of weeks here. So that's another thing on the backlog there.
Cool. Anything else before we conclude this week's meeting? Going once, twice. Then thanks everybody for attending today, and talk to you again next week.
Thanks so much for hosting, Michael.
Thank you, folks. Bye-bye.
Bye.
Cheers. Thanks a lot.
Thank you. Bye.